Wacha tuangalie.
Kwa sababu hata ndo hapo imejitokeza kati tuko hapo sasa hivi. Watu mwingine anatumia bini ya 5, mwingine bini ya 10.
Karibu at Chumbe namba 2 na exclamation mark.
Alafu huyu ni wewe Shabani, ndio? Hawa ni nyinyi. Hizi hamja correct. Hii. Kama hii.
Hawaja correct nini?
Sio correct. Kwenye observer hapa inafaa kutokea jina moja.
Hawajafanya, hatujafanya.
Sasa nani Msembi? Sasa irudishe hiyo transect ili aweze kuicorrect. Collector hawezi kuedit return hiyo nani. Hizo ambazo zina majina mengi return zote. Admin ndo anaweza return. Collector hawezi. Kwa hiyo zirudishe zote ambazo zina majina mengi afu waambie wazirekebisha baki ambayo
nirudishie kwa sababu nahitaji kubadilisha.
Zirudishe zote ambazo zina majina mengi ndio mimi niko na connect hapa nifanye hiyo. Kwa hiyo kama uko pale zirudishe zote. Hivi ni wifi ya nani? Ni Chumbe hii ambayo ina nani?
Kuna exclamation
Subiri, karibu.
This evening we are transferring the data from the field slates to either two tools. We're entering directly to Mermaid, which is an online software database, and also to Excel files which are templates that have been designed so that it gives summaries directly from after entries. You get all the summaries that you need. Right now I'm entering bleaching survey that was done by an observer. I'm translating these or transcribing them to Excel file, and after that I will do them on Mermaid. This gives us a diversity of taxa, coral taxa that are available in Chumbe or inner site, and also besides the taxa it gives us the number of colonies or diversity of colonies that are available, and also it can show us the percentage of coral cover and soft coral as well as algae which are within that environment. It's an activity that is done within a span of 40 minutes, and observer randomly swims on the reef and observes about 20 quadrats within the given time, which covers a bigger area and gets a good representation of the coverage of different measures within a short period of time.
Can you tell me all the things that you've done and will do this week? What have you? What kind of data? What data?
Yep. Good. So far we. Sure. Yep. Take your time. So among the things what we've done so far. You want to be there, or I should be there?
You should stay here, but okay. Maybe go a bit forward, like you were actually. Yeah.
Okay.
That's perfect.
All right.
It's just because of.
All right. Looks good. Or should I do this?
Let me come on the other side.
Okay.
And you can stay there.
Okay, fine.
And I'll just switch from here to there. Yeah. Okay, perfect.
Okay, I can go. All right. So what we're doing basically, we're conducting trainings on different methods that we can assess the reef, the status of a reef, and that includes bleaching surveys. We're also doing LIT or line transects to assess the benthic status of a reef. We also are planning to do predation, which is a process that we theta or sing or
the ones that you've done so far.
Okay, fine.
But the other ones you just say them fast.
We will do it.
Not we will do just.
No, we have done this.
We are doing this.
Okay,
basically.
Okay. All right.
Yeah.
Should I go? Okay. So what we are currently doing, we are assessing the status of coral reefs. One of the methods is to assess the fish biomass, and we lay transects, a 50-meter line transect and do 10-meter wide. which gives us 500 meters square, and through that we get the lengths of different fish families that are within that place, and we can translate the lengths to weight, which gives us kilogram per hectare, which is a measure that we use to assess the status of the reef. The other thing that we are currently doing is to assess the benthic status, which we use LIT or line intercept transect, where we lay a transect and evaluate all the coral genera and other measures for another characteristics such as sand. We look also at coral, soft coral, and also seagrass, which are available if they are there, and sand. This gives us the diversity of coral as well, and it gives us susceptibility measures of the environment or that reef in general, which also is an indicator of assessing the status of the reef. The other measure is also looking at the abundance and the diversity of sea urchins which are found within a place. And this also shows us if there are browsers or there are predators within the reef. Mainly of importance is the orange triggerfish or the Balistabas undulatus, which is a very important indicator within the reef and gives us also a status of the health measures. The other thing also that we look at is we are already conducting coral bleaching surveys. Bleaching assessment is a rapid assessment that takes 40 minutes. We look at all the diversity of taxa that are found within a place, and we, through the activity, we get abundance also as well, and also look at the percentage of coral cover as well as percentage of soft coral and algal turf or recently dead or dead coral reefs within that environment.
And concerning coral, what have you seen? What have you observed?
Yeah, so far we've visited at least 2 sites or 3. The first, what we did today, we were monitoring high compliance site, marine protected area, and the coral cover is about 80% in an average, which indicates that high compliance, no fishing is happening within this place and is well managed, compared to an area that we were yesterday, which is a mixture of fishing activities happening there plus low compliance, and you realize the coral cover was about 20%. So management has a very big impact in terms of the health status of a reef. Yeah.
Can you say the same thing by saying this place? Because I will probably put that on the images.
Okay, so this place, I mean, I should mention the exact place. You mean that?
Instead of saying yesterday we did, and
okay,
just say, okay, here we have, you
okay.
can say here.
All right.
Like this.
Got your point. Yeah. So here where we sample, we realize with high management or good compliance in this place, you have at least 80% coral cover. And when you compare with another place, in this place you realize you have, when you have low compliance or low management area, coral cover comes to 20%. So there is a very big impact of management with regard to its implication in terms of coral cover and associated fish biomasses that are recorded in these places.
And what does that mean for your work?
So in terms of work, when you have high biomass, it means there is high yields, and that translates to spillover effect, which means even the communities that are within these places and fishing around these areas, they get high catches, which translates to poverty alleviations and creating more income for the fishers. Where there is no abundance or there is less fish which are found within the place, there is low productivity, there is low yields as well, and it translates to low income for the persons that are dependent on these resources. Yeah.
Very good. You're very good.
Thank you. Okay. Thank you. Let me see how the here.
Ready.
Nice.
Okay.
Good evening. Yeah, I know we are all very busy. We just needed a few minutes of your busy schedule time.
Few minutes. How many?
Few minutes can be 45 minutes if you we just need it. So the whole idea, we wanted to go through how we are entering data, Mermaid, as well as to the Excel file. The Excel file, I don't think we have a lot of issues with it. so far. The mermaid is where we want to agree on some different things. First of all, for biomass, I realize there are 100-meter line. There are a lot of numbers there. 50 and something.
In the mermaid,
Yeah. So all of us have been using 50-meter line, and then the width is 10-meter line. And that is how we actually, from the word go, from Peter's explanation in biomass, you lay your transect 50-meter line, that is, and then you swim 2.5 meters away from the line, right? And then you sample 2.5 meters to your left and to your right from that 2.5 meter line that you've created in your mind, if I have to say that, right? And then you go all the way to your 50-meter end, you swim to the other side of the 50-meter line, create another 2.5 meters of it, sample 2.5 onto the left and to your right, to the end. And in so doing, if you had sampled or if you chose one of the families, only that you took one family, then you need to go all the 24 times. But based on Peter's thoughts was, go with the fewer things, and then you sample for macentries and labridae at the same time, which means you do maybe 2 trips, depending on the abundance and the diversity that is within the area. I don't know if I'm making sense.
Yeah, it's making sense.
Yeah. But otherwise, if you chose, I want to go with Janidae all the way, that would be, if you go 2 trips, 1, 2, that would be one family. And you say, I want to go for Scaridae, that would be 2. So that would mean at the end of the day, you need to go 24 times. So it depends on the method that you use. But at least the important thing is, from the 50-meter line, you take your 2.5 meters far from, 2.5 meters approximately from the transect. Then you sample 2.5 here and here. That makes 10, which comes to 500-meter line, right?
But I wrote it 100 times.
No, that's the point now. It's 50 and then you did 10.
Now I know, but
Yeah, that's what I'm saying.
It's
We
the
are
same
correcting each other.
Same maths.
it's the same math.
It's the same math.
Yeah, so that's
It's the
why-
same mark.
When I entered the
Yeah,
data,
it
it was
wasn't
only
very
open
much.
access or managed area, and then somehow.
We need to standardize. At least that's one of the things we should be telling each other. When we talk of here, this is the management, we should all input to that. The depth will vary depending on where you lay your transect. And that's why I think most of the people have gauge, the depth computer, what they call computer. If you don't, maybe seek from someone you can ask me, because I'm working with you anytime. The depth, we have the gauge, so that helps to get the depth measurements.
Can I say one thing about the sites?
Yes.
One problem that we typically have is that when you're doing a survey, the first thing you do is that you add a site, which is really not the way it should be. You should be importing a site, an existing site,
Yep.
from your database.
Yeah.
Because if you don't do this, then you're not going to be able to link the data you are collecting now to the data that you collected in the same place, but maybe last year. Right? They end up being into separate, records basically. So you always need to import a site from an existing project so that it's linked, the links of the data together. The way we do this, we have one project that has only and all the sites.
Yeah.
And whenever you want to add a site, you add a site to that project, which has no data, it has just the sites,
Yeah.
and then import from that project into the new project.
Yeah.
Yeah, because
Usually a
this way
process.
we have like a database of all the sites.
Yeah.
That is clean, it has all the GPS points that we're
Yeah.
sure what they are and so on, and just keep importing from it.
And if there's a new one.
Wait, stop it. No.
He has the famous paper of
Ngapi hizo nataka niongeze.
18, it was 18, so okay. 20.
20, yeah?
Not your day, guys. Lucky you.
Oh,
Back for your wife.
he's gonna find
Or
a
wives.
Why?
Culturally, they should have wives.
Probably a polygamy.
Someone collected even this.
Right size here.
So what are we doing?
You're
here,
counting
guys?
now?
23. We are selecting good sizes that we can skew up and put monofilament line on them. This is okay. 20 what are you counting?
No, you stopped.
That is 20.
That's what I just asked you. Are you counting? No.
John, what's yours?
23.
22? Okay.
Okay, 22.
If you've got biomass, we can just weigh them, right?
23.
So you're going to die. So you have to be now.
Mm.
24.
What's
Sorry.
what is the whole purpose of what we've been doing today?
What is the meaning of life?
To live and to reproduce.
And to eat sea
This
urchin.
is we are doing a predation experiment. So this is a species of sea urchin that we are going to skew
25.
and make a hole,
26,
put a monofilament line, and then lay them on the substrate, on the coral substrate, and then let them enjoy life there for 24 hours. And then in the morning tomorrow, we're going to see if they have been predated or if they are still alive. If they are still alive, lucky them, we'll release them. And that is going to give us an indication of predation in the reef.
Thanks. And why is it important to see the predation in the reef?
Predation is one of the processes within a reef that maintains the health of a reef and keeps everything in balance. If you do not have predation, for example, for sea urchins are bioeroders, so they will, as they move their span, they will be scrapping the surface of the reef and making the framework weak. So in an event of strong waves or something, the reef is weak, so easily gets damaged or everything is physically damaged.
41.
Thanks.
What is the natural predator of sea urchin?
There's some invertebrates. There's, I think, the bullmouth shell is one of them, but there's some labrid wrasse species also that predate on sea urchin, but more important, the famous one is the orange line triggerfish that has been used as an indicator of health reef or predation in the region. Based on our biomass data, there is some there, so hopefully we're going to see some predation.
Is the animal gonna suffer when you secure it?
No, we're going to put some anesthesia on it. No. We are going to do it nicely. It's not going to suffer. If they are not predated, tomorrow you'll see they'll still be alive, and we'll release them and take them back to their families.
We'll bring them back here.
Yeah.
Is that right?
3.
No.
And can I ask, Ben, why did you get so many of them?
Me, I was just carrying a bucket, so I was saying no, leave them, and everyone's like, no, more. I said, leave them, it's not nice.
Yeah, I think from our first experience there, everybody was like, now we are here. Collect as much as you can. There we would have stayed for 3 months, maybe.
And having so many here, what does that mean? Does it mean something?
Maybe there isn't any predators here.
Yeah, we should point out we are outside of the park.
Yeah.
Yeah. Oh, yeah.
So
that was
you
the purposeful exercise.
You found a lot outside of the park, basically.
Yeah. Yeah.
Can-
But these ones, yeah.
Can you? So we won't hear my voice. So can you? Yeah.
Yeah. Repeat the question.
You have to just
So
say that we are outside.
Where
the
are
park.
we? The fact, do we see more urchins here than in the?
Yeah, 56.
Yeah, so we are just outside
Almost at
the
60.
park, the no-take protected area. That's why probably there are so many sea urchins here. And I don't know if you observed when you are collecting, there isn't any fish swimming around or any other species. So likely that's why there are many here.
Thanks.
Probably let us add more 10.
Yeah, I think John said 100.
We said we clashed a lot of them last time. Let's get more.
Yeah, so we can just 100.
It's the face, no?
It
Like,
is
me sitting around
important
smiling.
because
I might get a
as
job in
we
Madagascar
see,
though, with the ministry, no?
the
We like the guy that
natural resources are being overexploited along the years. So we need to do basic studies like this to evaluate the status of several natural resources like fisheries, sea urchins, sharks and rays. And as you know, WCS has the goal to protect the ocean and wildlife. And we have several different programs across the world and across the Western Indian Ocean in Mozambique, Tanzania, Madagascar. And we have different types of different experts in the area, and we are using different methodologies. So part of the goal of this training is to kind of like learn with others what they are doing, gain experience, and even harmonize the methodologies that we are using across the countries. So for me, it's new. It's a new knowledge that I'm gaining here in the training. For example, with the sea urchins practice that we're doing today, I've never done predation study, so it's interesting to go under the water, collect sea urchins, and then see by tomorrow what the predation rate will be. So yeah.
Guys, can I ask you just to not speak too loud because I'm not sure I will.
Too loud.
Thanks. Sorry, you can continue to speak. But
you guys.
And so, what have you? What are you harmonizing on? What kind of studies?
Here, mostly coral reef monitoring. 2 days before, we were doing fish biomass, and then we studied also substrate. So, yeah, learning these methodologies is new for me. And yeah, it's different from what we are doing in Mozambique. In Mozambique, we use photo quadrats and we do scuba diving to do this kind of studies. And here we were doing snorkeling, so this is quite interesting. Yeah.
Thank you.
It was in one of the
So, yeah, you've been organizing this week. Why is it important to harmonize?
Yeah, it's important to harmonize. We can have a comparative result in terms of coral cover, in terms of fish biomass, in terms of all the variables we are monitoring under WCS, both in the region, Mozambique, Madagascar, Tanzania, Kenya, so that we can have a comparative result in our data, and then we can have informed management interventions even to the managers who are dealing with the conservation in the region.
Can you describe a bit? And this will probably not be. You won't see yourself. I use it to put under the images that we took of the training. Like, can you just explain, like, what you've been doing and why? Like, all the activities that you've been doing, the protocols, and can you explain the different types of things you've been doing?
Okay.
But like, it's not my question. You can just like narrate, like just think that there will be the images of you snorkeling, seeing, putting the lines and like checking the fish, the biomass, everything. Just explaining these things.
Yeah, okay. The team will be doing several kind of assay or method to undergo the assessment. For instance, for the biomass, participant will be laying the line, whereby then they will do the assessment to have an estimate of the biomass. Then the team also will be doing the hatching count. So here we are collecting the sea urchins. Where now we are going to do the tethering to account for the herbivory. Herbivory means we are going to deploy the urchins in the reef where we have been doing the assessment. The predations of the urchins will tell us an information on the existence of the fish who are feeding on the urchins and an indication of the fishing pressure or the MPAs. If you find the urchin being eaten, it means you have a lot of predator who have eaten the urchin, and then indication of the most of the MPAs which are effectively enforced, and we expecting the chumbe is among such MPAs.
Can you explain what you've been doing yesterday, for instance? Just explain biomass and the list. Yeah, it's okay. Yesterday we not saying yesterday, because it will be a thing about everything. We can say like, okay, LIT, it is this.
Okay.
LIT
And the fish eagle as well.
That's okay.
This is LIT and what it is.
Yeah, we are doing LIT. LIT, we are laying a 10-meter line, whereby we do the assessment of the categories of the along the line, and we calculate mainly the percentage of the coral cover and the rest of the substance along the line. With several lines, then we are able to calculate and understand exactly what the percentage coral cover of the MPA in the reef. So that's the lead. For the biomass, as what we are doing, we are deploying a 100-meter bait transect, and then participants are counting now the fish within the bait, estimating the size, doing the diversity, the different species and the families within the bait. That's an indication, as an index of the biomass. It gives us the information on the management effectiveness of the area. For instance, now we are going to have a clear image, clear picture of the chumbe MPAs in terms of management effectiveness by looking at the index of the biomass. Yeah, that's how it works.
Thanks.
Okay. Yeah, can I have a line?
I think this one's got holes after holes after holes now. I feel like letting it go.
Much.
You had a party
It's much
and
better life outside of the actually,
Okay, so look, I've only got 6, 7. Any 8?
Yeah.
Oh, what's your head? Okay, it's now you got an earring. 9, 10. Okay, next row.
Is this 10?
This is 10.
So, can you take all them out and I'm move them?
I can do that.
Yeah. Okay. Can you hold it? Okay.
Hello, you. Okay, 1. You know what?
Can I have a light?
You pass me those ones.
Right.
for 4. Just thinking I can scoot right through one.
Cosa leggere, le bête.
Who's ready? Oh.
They're enjoying with their friends. Having fun.
One for you?
Bene.
Yep. 1.
The
2.
big one, they get them inside.
3.
Just one Alphonsus, just one species.
3.
Ça a été la survie?
Yeah. 4.
Pas beaucoup d'espèces. C'est beaucoup les mêmes.
On n'a pas pu. On n'a pas pu.
Ah, ça t'as pas vu?
Non.
Au début, on n'en trouvait pas beaucoup, ils étaient bien cachés. Et puis on a été en dehors du parc, partout, un champ.
En dehors.
Seems too small. I'm gonna throw him in the sea. Give him the best of his life. 2, 6, 7, 8.
So 3 days, and so we are going to find them in the reef. And then wait tomorrow we come back and see.
So this one is like a bar, how to say that in English?
Ouais, a bait.
A bait, yeah.
Et-
9.
Oui et non. En fait, on n'emploie pas vraiment comme bait pour attirer quoi que ce soit, mais c'est vraiment pour calculer en
9.
fait, le pourcentage, donc combien ont été mangés, et après ils ont un indice qui leur permet d'estimer la prédation. Pas tout à fait comme une proie. Si tu vois ce que je veux dire. C'est nouveau.
C'est
shrimp.
Ah,
No, it's a shrimp, huh? I think.
Ora poco poco.
Oh,
Was it flat one?
No.
No,
Like
these
a
are
arthropod.
some parasites, no, copepod.
Nice.
Can we put on this one or no?
Yeah, 10.
Done.
10?
And here another one.
Okay, 2.
Thank you.
I'll put in this pocket tomorrow.
Nice. You're wondering what's happening. You're like, we were waiting for you to lay out there.
Jen, can I have a light?
Lay them?
Yeah.
A light? Yes.
Here you go. You have more than enough cigarettes?
We haven't even started the seals.
Trade you.
There is also this aspect here.
I'll trade you. Oh, you have the seals.
I'll put it in the pocket for you.
Why you had happy cheek? Who has any needles?
Ah, there's There you go. I'll give you one. Here.
Damn, these are not needles.
What? To make a hole. Beat you? No. I was actually looking the seagulls. I used to make a hole. My hand. I used to make a hole.
Anyone has a useful working needle?
Yeah, here. Not a day. 4, 5, 6, 7. Counting? Yes. Here.
Next.
9.
Should I pick from here? Nice.
Give me the husband.
You guys should have tasked Peter to do this job.
Why?
Huh? We usually do it the two of us and just the two of us. So I'm wondering why he hasn't finished that himself.
He says it's his favorite thing to do with you, right?
Usually the two of us do 60.
When you want to chill out, you just...
So we usually do 6. Is it complete?
No, 3,
Okay.
6, 9. That's the last one.
10? Okay.
6, 9. Finish.
3.
Where should the extra go?
Here.
Here.
That should be the last one. The last one. Double count, that should be 10.
So we go out now. It gives us an indication of overfishing or not, but in this reef that we are currently, it's not overfished because it's a protected area. So the effect of management on resource is really good in this place, and it's effective management. Yeah. Thank you. What did you say? I said good job everyone. Amazing. Sharing good. We are feeding the fish now. Okay. Perfect job today. Every team member has been very helpful and they did really the best they could. We managed to do predation and also herbivory as well as sea urchin counts, which are also good indicators to assess the status of the reef and the fish that are present within the reef.
Is it important to do that kind of stuff to know about the resiliency of the reef?
Yeah, it gives us an indicator because when we have when we evaluate the rate of predation, it gives us an indicator of the amount of fish that feed or predate on the sea urchin. So it gives us the indicator of predators, and this shows us the different fishes that play different roles within the reef. So presence of more predators means minimized sea urchins, thus ability for corals to flourish within these environments. Yep.
And so you can see with that kind of, you can see like if there's overfishing somewhere or not?
Yes. So with this, it gives us an indication of overfishing or not, but in this reef that we are currently, it's not overfished because it's a protected area. So the effect of management on resource is really good in this place, and it's effective management. Yeah.
Thank you.
Island that was when sea level was 5 meters above what it was 130,000 years ago, and now this is now where the reef is forming. It's formed, and it's an edge just like most of these things. There's an edge here. We're here, I think, at the tide seems pretty high, but I don't know what it's kind of mid-high tide.
11. Yeah. 11. What's that?
Okay. Anyway, so you kind of have a coming off the coral start here, and then it drops into about 18 meters, I think, and then sand. So you have between sand and sand. Probably what I would do is it's probably good to do some transects in a few different places. I remember last time I did mine was around 8 to 10 or 12 meters, but I was pretty close to the end of the sand at the bottom. I enjoyed it because there's a lot of little rapids and more fish down there than in the shallows. But so maybe as a group, you might have a couple of people do some of the good stuff right here by here. Maybe some along the edge and maybe some at the bottom to just get a bit of the, unless your idea is just to compare yourselves, but if I, as an ecologist, I would want to know where the fish were located and whether my sample was affected by where I placed my transect. So if it was me, I would probably want to do a transect right here. I'd probably want to do one just as it got deep, and then I'd want to do one on the slope. So sort of a flat, crest, slope, right? That's kind of the three places that people tend to refer to descriptions of stuff. So maybe we can, you know, and by the way, there's some urchins there, so I would want to sample those. Not those ones specifically, but I would randomly like to sample. And see what they're like here. There used to be a lot of urchins here. I can tell already they're not like they used to be. But we had a lot of, this place was full of urchins 20 years ago, by the way. So maybe pick groups. People that are maybe less experienced in diving, why don't you do this reef crest? And when you do it, go down to the deep before you come up and eat your chapatis, because it's very nice down there, you know, to see what's along the edge. So enjoy yourself as well. Those people that do the reef crest, that's where the life is going to be most abundant, and even on the slope. But if you feel like there's not enough time for a 40-50 minute dive, I wouldn't do the sample at depth, unless you're just one of those people that doesn't use a lot of oxygen. So think about that. How do people kind of know how a tank of air of say 200 psi, how much air they would use? How long would it take you to empty that tank?
Yeah.
Think about that. If you don't know it for yourself, begin to know it, because that actually becomes a thing you have to, when you go beyond sort of pleasure diving and into actual work diving, it becomes a calculation that you have to think about. So for me, for example, I don't do fish transects below about 17 or 18 meters depending on the depth, because I know for me to do the full DGS, I would now be entering into dangerous territory beyond that, because I know my consumption of air at 3 meters might be 2 hours, but my consumption of air at 18 meters might be 50 minutes. Okay, so I know that about myself, and you should start to learn that about yourself, because you don't want to do stupid stuff and agree to do things that are dangerous. So if you want to spend a lot of time in the water, why don't you spend it here in the 3 meters? If you want a little adventure, go down there, but don't do a DGS when you don't know all the species, and you haven't done 10 or 15 at 10 meters, so you have a sense of how long it takes you to do it. So for me to do a DGS, which is about 6 passes of the transect, it depends a lot on what the currents are like. Here there are no currents, you're in the most benign conditions, but in many cases I'm in currents. I can even use all my air up in 45 minutes, which for me is fast. But you know, Witta, who would be with me there, she would last about 60 minutes. Okay, so that's even another thing I think about, is who is my buddy, what is their air consumption, how deep can we work together and feel safe, who would be, in case of emergency and you had to buddy breathe, who would be buddy breathing from who. And that unfortunately has happened many times where I've been stuck at 30 meters.
Okay, I'm ready.
Yeah, so the world is talking about problems related to climate change, and what we have seen in the past few years is the occurrence of extreme bleaching events, big bleaching events. And let me start over actually, because Tim doesn't like extreme. Okay. So what we've seen in recent years is the occurrence of bleaching events, and these are being very damaging, and there's a lot of people that think that we're not going to have coral reefs in the near future because of this. But luckily that's probably not the case, because what we've seen here in in Zanzibar and many other places like Zanzibar in the region is that there's a lot of reefs that are likely going to survive this. And we've seen places with very good coral cover, very good diversity, good fish communities and all. And these are good examples of reef resilience, reefs that have a good chance of surviving this climate change coming in the near future and so on. And so we are quite positive about the outcomes of what it could look like in the future. Of course, this doesn't come as on its own. I mean, there's a need for protection, there's a need for conservation, a need to put in place measures that actually preserve these reefs. They can be damaged by a lot of other reasons, by using damaging gears, by not effectively protecting them and so on. Overfishing them is a big problem as well. And so there's a lot of threats around these resilient reefs that are still there. And we need to find ways to, to maintain and preserve them as they are. And there's solutions out there, luckily. We saw examples of effective conservation, for example, in Chumbe, one of the nicest reefs in this region. And it's an interesting model. It's privately managed, generates revenues through tourists and so on. The communities accept the place. They understand the importance of having good, healthy ecosystems around the fishing grounds and so on. And so there's ways to do this, and as WCS we are trying to implement some of these solutions as well. We're helping governments, we're helping communities, we're helping all the stakeholders to try to find solutions to protect these last remaining coral reefs and ensure resilience of the coral reefs in the region for the years to come.
Yeah, you talked about everything, I think.
Yeah. I can do it one more time, just
maybe slower.
Yeah.
And just like, yeah, slower, just paced and like just one sentence.
Yeah,
one sentence.
Short sentences,
like,
yes.
Not as an interview, but as a
narration.
As it keeps on the images, right?
Right.
Ready.
How to start?
So
no, I know what I want to say. I just don't know how to word that. So the recent global bleaching events really sort of left us thinking that we are not going to have coral reefs in the future. And this is of course a risk, and it's possible that that's going to be the case. But what we are seeing here is that there are in fact places and coral reefs that are resilient to climate change. These places, the places we just surveyed in the past few days, are places that show good, healthy coral reefs. We've seen high coral cover, good fish communities, and in general reefs that seem to be surviving the effects of climate change. Of course there's been bleaching. In 2024 there's been a big bleaching event, and these reefs were somewhat damaged as well, but they are recovered. And the community, the coral reef communities seem to be adapting to this different climate. They seem to be responding in a positive way. And we see some positive coral reefs, some good coral reefs in these areas, which we didn't necessarily think was going to be possible. And there's plenty of examples of success. We've seen Chumbe Island is an island that is privately managed. It's a marine protected area. It has been protected for the past 30 years. And it shows very healthy coral reefs and fish communities. It's an area that is, it's an MPA that is accepted by communities, by government. Everybody understands the importance of this place. And it's an example of conservation that can be replicated, can be used in combination with other forms of conservation. Communities can be effective at ensuring protection of coral reefs. There's a lot of examples of successful community managed areas. The government also has a role. There's examples of government-managed marine protected areas which can be effective as well. So we think there are ways to protect these resilient reefs, and we've seen a few of these examples in the past couple of days.
Maybe
so resilient reefs exist. We see examples of coral reefs that are adapted to climate change, like this reef, which really shows high coral cover and good integrity. And is an example of a reef that survived the recent climate change event, and is different from some other reefs that of course struggled and suffered and died because of the recent bleaching event, like this one. And different reefs can support also different fish communities. We see reefs that are very healthy, that have good corals, but also good fish communities. Like this one in Chumbe is really an example of a healthy coral reef, healthy fish community. Not as pristine as we might want it, but still very good for the size of this MPA and the condition of this MPA. And it's a really positive example of how coral reefs could be managed, which is not the case, for example, in some other areas that we've seen, like in Bawe Island, where the corals are in somewhat a good state, but the fish communities have been depleted by the years of fishing in these places.